I'd like to show you how to compile a Java file using javac command. So let's start with the first part by talking about what is actually compiling in Java. So when you create a Java application, the very first thing you do is to create a Java source file, which has the source code. After we create the source file, we need to compile it into a bytecode. Bytecode is the language that the virtual machine, Java virtual machine, can understand. Once Java virtual machine has the bytecode, it can run it on any operating system. So basically, we can here see all these layers between Java virtual machine, operating system, and hardware. So what the Java compiler does is the very first step of this chain, which is converting Java source code into bytecode. So yeah, let's see how this javac tool actually works. So in order to do that, I will first start by creating a Java application in IntelliJ. So let's start from the beginning, creating a new project. We are not going to use any library or framework, just simple Java without any template. I will just simply click next. So generally, when you create a Java application or in any other application, all the source files are saved in the source directory. So we will keep this tradition also here. I will simply create a very basic Java source file. Let's name it application Java, and we need a main method inside it. And we also need to give the arguments, of course. We will simply print an hello world message. Okay, so now let me make this a bigger screen. So right now, as you see, we only have our source file, and this is just a default file that the IntelliJ generates. So what we want to is convert this source file into a bytecode. So we will simply type our class name and Java compiler. Oops, I forgot to mention that it's in source directory. So when the Java compiler runs it, it automatically creates the class file in the directory, in the same directory where we have the source file. So this was the first step of Java command. Now let's move on to the second part. In this part, we will see how to set the destination directory for class files. So in order to do that, let me add a package information. So in this part, we can simply define where we want to put the output of the compiler class files by D flag, which stands for directory. So as a tradition, we will put all the class files in under the boot classes, and the rest is the same as we did before. So now when we check our project directory, the class file will be the bytecode will be saved under build and classes. So we can also extend this feature by adding a package information. So far our class doesn't have any package, but we can define a package information by simply adding these two lines. So now IntelliJ tells me that it doesn't correspond to file path. That's totally fine. So what we need to do is actually create here a package, which is just a simple directory, or we can just let we can just work like this. It's also no problem. Let's keep it, don't change it. So now what I'm going to do is we will build the class files again, but now this time you will see the difference. So now when I go back here again, now we have our this package directory, which is the org.example. So we can also see it here. Oops, we also see it here. Org example and then application class. So that was, now let's move on to next level. So in this part, I would like to show you how can we compile multiple files. So far, we had only one source file, which is the application.org. But let's say we create two very simple files as well. I will also give them a package description. Let's say, yeah, accessory and back. We will only have the color information and that's it. And I also want to create another class file now, accessory woman, and name it purse. And we will simply define also another, let's say brand, another attribute, string attribute. Okay, so now we have it. And we want to use these informations, these classes. We want to compile all of them before we use. So what we do is we can simply add all the classes in the same javac command. So just very similar like we did before. Now I will just give a white space and then write the other class names as well. They are also under the source directory and they have this packaging structure like Java, and I hope I'm not doing any typo. Okay, let's see. Source accessory purse not found. That's interesting. That's very correct because I forgot that woman. Okay, so let's check what we have under the build. Now we have accessory package and we have here our class files back and parse. So that was the first way to do this. And another way to do it is imagine that you have tens of maybe hundreds of classes, and each time you compile, you can just create a very big Java command on the command line. It's too tedious. Another way to do it is creating just a simple file. Let's name source files list with text file, and basically in our source files list we will put this function there, so we will just put these class names. You can either use white space, or you can either give the next line, and let's give it, and let's save it. So next time when I'm compiling, I will still do the same, but this time we will put this symbol and then the name of the file that contains our source files list. Yeah, in order to do this effect, I'm going to delete these class files here. Let me delete these ones. Okay. Now we have the build directory again with the class files that has been generated, which has the bytecode. So that was it, how to create how to compile multiple source files. Now we can move on to the next step. The next and the last step is dealing with a compiler error, which is a package does not exist error. So I have created 3 examples for this, and let's start with the simplest example. In order to generate this error, I'm going to import this this newly created accessory man back. I don't even need to create an object of it. It's just enough to mention this. And just to get rid of this red liner error, let's simply remove it, this package information. I don't want to create another directory here. All right, so now let's move on. Same what we do. We can use our list. Okay, now it creates. Now it doesn't give any error. The reason it doesn't give any error because we already have these class files in our build directory. But if I delete them, that's weird. So okay, in this example, let's add a new, let's import this newly created class names that we just generated. Accessory, oops, accessory woman purse. And now we want to build, now we want to compile again. You see, we have this package accessory woman does not exist. That's very logic because we didn't compile this object yet, this purse object. When you look at it here, it's in another. That's very normal because we don't, the compiler doesn't know where to look for this class. So in order to avoid this issue, we have two options. The one option is that we can use this existing class that we have already built. So only thing that we need to do is tell the compiler, oops, where to find these class files, and that's we do it by changing the so-called class path. And our class path is same as where we built the classes. So now, without any problem, we have created our application class. So now let's go to the second example. In this example, instead of using the class files directly from our build directory, I would like to create a zip file. So this will increase the complexity a little bit, just like real life case scenario. So now I want to zip accessory folder. Let's compress it. That's great. And then I will copy it. I will create another new directory called lip, and I put it here. So by doing that, I will remove all our previous created builds. So this is a very that's a gift that this is something that you can also experience. So now if we go back here and if we try to run this command again, we will face the same issue because the compiler doesn't know where the package is. We changed the class path, but this is not the class path anymore that we have the woman class. So it's in our lib directory, and to overcome this problem, we will simply add another directory. And in order to do that, I will put a double comma, a semicolon, and then define the other directory, which is lib, and then accessory zip. So by doing that, you can create different layers in your project structure. You can put all your libraries, jar files, zip files in a separate directory than where you create actually your classes. So this way it's much more cleaner. And the last example that I want to show you is using a jar file. So I have already have one example. This is the Eclipse MQTT project in GitHub. I will download it. I will clone it to better say, and then we will build a Java jar files, and here it also explains how to do this. So where is it? You can also do this with any jar files you already have. Okay, now we will build it. Okay, it failed, but it built it. We must have right now our GitHub, our Eclipse Paho. Yes, that's great. Okay, now let's change directory. Oops, Paho. And now let's build it. It will take a while to build the jar file. Okay, building is done. Now we must have the jar files. When we look at here, okay, we have this target, and here we have the jar file that we needed actually. So let's solve this problem. So first I want to use this, as we seen in the example, I want to use a class from this jar file. A very simple MQTT class. And let's try to run like we did before. Okay, and we see, oops, sorry, I need to go back again. So let's run again. So as we see, we get the same compiler error. Doesn't exist, package does not exist. So how do we overcome this issue? Okay, let's define, okay, let's copy this jar file into our lib. And now, yeah, file name. Now we will do the same thing again, but this time we will add the new jar file name. Ta-da! As you see, we have built successfully. So that was it. That was the last example that I wanted to show you regarding the compiling. So now we covered pretty much a lot of things what you might have faced when you deal with the Java compiler. I hope you like it.